OpenSource SenderReceiver framework, which is a mouthful, and that's why I usually call it OSERF, which is quite fitting here in California. And what's OSERF? NMOS, as any specification that wants to be adopted, needs to, or at least should, have some way of simplifying the implementation, the usage, so quickly getting people to start using it. And one of the biggest helps we can have when doing that is to provide open source software. And actually, NMOS has been quite good at that. So if we look at media node development and testing, we've been having for a long time interesting work around testing, namely the NMOS testing tool. Since the beginning of the specifications, there's been good support from an open source testing tool, which has been used, for example, in JTNM tested, and is invaluable for you to test your media nodes, your controllers, to guarantee that or to give you a certain level of assurance that you're actually following the specifications. There's also another tool that's widely used called Easy NMOS, and that bundles together a registry, a series of mock nodes, a controller. So very quickly, with the few commands, you can spin up your NMOS registry, you can launch mock nodes, and you can control them. Those mock nodes don't actually produce or consume essence, and I'll get back to this later. So this is on the testing and experimentation side. In terms of the actual media node developments, there's a wonderful library called NMOS CPP, which implements most of NMOS. It's completely thorough in terms of the different specs that are implemented and the quick speed at which new specs get supported by the library. And I like to look at that as a set of Legos. So you have all the pieces you need to build something, but you need to have the imagination and the time to actually construct something useful. There are some other implementations. One of them, NVMOS, NVIDIA made this open source recently, which builds on top of NMOS CPP and is designed to work closely with other software and NVIDIA hardware so that users can have a simple way to get something working. I like to look at this as, you took the Legos and you built something, but it's quite rigid. So maybe it's not even Legos, it's plywood that you cut and glued together. So there's a gap in the middle, and that gap is you're the developer, maybe you're an intern or a junior developer that were asked to assess NMOS and try and see how fast could you get NMOS integrated in your product. And given the fact that NMOS CPP is quite a big box of Legos, it may be a bit daunting and difficult to get quickly to a result. So we thought that there was room for something that was a simpler path, a quicker path to have something done. And that's why we started this sender and receiver framework, in order to provide higher level building blocks. So you still have the ability to tweak everything to what you need because it's built on top of NMOS CPP, but most of the groundwork is already done, and hence it's simpler to use. So what is it? Well, it's a library. So think of it as a layer on top of NMOS CPP with a simpler API. It's also, and I'll get back to this more thoroughly, a set of GStreamer plugins, and I'll explain why. And also demo applications that show you how you can quickly launch an NMOS node with senders and receivers that actually send and receive data, right? So unlike what we had thus far, they actually send and receive, in this case, ST2110 streams. The goal being, obviously, to simplify the implementation of NMOS media nodes. Where it is? On GitHub. So you have the link there. It's easy to find. It's easy to get started. And when is it available? It is available now. Actually, if you go to GitHub, you'll see the repository there and the README with all the information you need to get it started. Part of this repository is a Docker file that builds a Docker image with everything you need to compile and run if you want the software, so you don't need to install anything, support libraries and all that. It leverages tools like Conan to download the packages that you need, CMake to simplify the build process. And the way we developed this was firstly on phase 1, which was released around IBC. We implemented the library with the simple API that I mentioned. And we built a couple of demos. One was a sender, another one a receiver for 2110-20 and 2110-30. But obviously, this being software and not accelerated by any means, the resolution is limited to very low resolution, like 320 by 240 or something like that, right? So depending on the machine, the resolution will be larger or smaller. It's not compliant with -21. So the goal here is not to make anything that's compliant, is to give you something that actually works, that you can see, and most importantly, that your developers, or that developers in general, can look at and see, well, if I want to do something similar, this is the point where I need to insert my own code, because everything else is already there. Then we thought, well, still, maybe we can make this a bit simpler. And one way of making this simpler would be to use GStreamer. Probably most of you are familiar with GStreamer. For those who are not, GStreamer is an open source project that's been around for a long time. It lets you build media processing pipelines. So it has this concept of elements with which you create a pipeline. And it has this interesting duality. So on the one hand, you can build a proper application with that, where you embed GStreamer. On the other hand, you can use a terminal to quickly whip up a pipeline, launch it, and see the results, change parameters, run it again, and see the results, right? It's a very interactive way of developing an application. This is nicked directly from the Wikipedia. It's an example of a GStreamer pipeline where you see a graphical representation of such pipeline. And then in the bottom, you see the syntax that's used to launch this in the pipeline. It's a bit cryptic, but once you get used to it, it makes a lot of sense. So what was our goal? Well, to develop a couple of GStreamer elements, one source and one sync element, so that we could create a pipeline for sending, a pipeline for receiving, and then we could use NMOS to connect the sender to the receiver, and data would flow. So this is what we did, and we released a couple of weeks ago, a month ago at tops, the phase 2 of this development, including the SAD GStreamer plugins. You just go to GitHub, look at the README file, and very quickly you can have this running. I decided not to run the demo here, but just for safety reasons, I asked one of my colleagues to record a couple of videos, and that's what I'm going to show you. So firstly, demo 1, my colleague used a series of terminals to launch 3 GStreamer pipelines, so 2 video senders, 1 video receiver, and then using one NMOS controller, in this case it was Matrox Conduct IP, could be anything else. She connected the senders to the receiver, and you can see that you can switch from one to the other. So hopefully the video will play. Maybe one needs to press a button, I don't know. Yeah. Tina, I guess I need some help there. Is it possible to press or to click? There you go. No, I don't think we're seeing the video. Well, if it doesn't work, I can always show you on my laptop. Okay, don't worry, let's move on. So the second demo, we use 2 senders and 2 receivers, and you can cut from one to the other. And in this case, it's using another NMOS controller, Easy NMOS, the one that comes bundled with NMOS.js from Sony. So there's the other video. I don't think it will work if the other did it. Well, I'm sorry about that. Anyway, if you want to see those videos, just come and find me. I have the videos on laptop. So that's it. Call to action, go there and try it out. And more importantly, the next steps. So what should we do as next steps for this project? Well, I think that this will be much or completely driven by requests by community. So please step forward and tell us what you think of what we have so far, what you think would be interesting, and most importantly, contribute to it, either by submitting pull requests or to criticize and suggest